Okay, let's take a look at using pointers. So, as usual, I've shown a computer block diagram here where this represents a couple of registers in the CPU and this represents the program memory. Notice that if we look at what's in the address register, it's pointing to address number 0, which is this one right here. And then inside of that register are the contents or the data. You can see that that data is 20A5, which if we were doing a read would be loaded into the data register here so that the computer would then have access to the number that's stored in there. Here's some other addresses, address 1, 2, 3, etc. Here's address 8. What we would have in here would be the contents. We're going to assume that this contents is all kind of random here as we begin. And then we'd like to look at what happens if we try a few C program steps. Suppose now that we take a look at the C statement, A is equal to 9, and we'll assume that A has been set aside by the compiler to be in location 8, which would be right here. So first we would place an 8 in the address register. Let's go ahead and do that. Okay, so we put an 8 in the address register. The data register already has a 9 in it. Now if we do a computer write, this will go ahead and go down to location 8. This 9 will then be placed into that location. So this is then our result. Location 8, which is A, now has a value of 9 stored in it. Now suppose that we use this statement. We define a pointer, star B, and we set it equal to the address of A. Let's also suppose that the compiler has identified this location, location 3, as the place where this pointer, star B, is stored. Well, this statement then causes an 8 to be written into location 3. Remember, the pointer is stored in location 3. When we set that pointer equal to the address of A, we see that A was address 8, so an 8 is now placed into this location. If we now have the C statement, C is equal to star B, this star now indicates the indirection operator. This will follow things through in the following way. We'll go to B, which is right here, location 3. We'll look at the address in B, which is an 8. We'll go to that address in the memory. We'll take the contents of that address, which is 9, and we will then place 9 into C. So C equals 9. This is also sometimes called an indirect address operation. Now, this gives us two ways to access the number in location 8. We can do it directly by using the symbol A in a statement, so C equals A, or we can do it indirectly by using the pointer, which is an address 3. Remember, that pointer points to address 8. And so we can say C equals star B. Either way, C is now equal to 9. So we see that there are three important things that happen here. First of all, we define a pointer by using int star B. It has to have the same type as the variable that we're pointing it to. Then we reference that to a particular variable by saying that it's equal to the address of whatever variable we want to use. Then in the program somewhere, if we want to access the original information, we use this star B as the notation. And again, what it means is follow the pointer that's stored in B back to the original location, take that information and load it into C. So follow the pointer is stored here, it points to here, take that information out of that location and put it into C. Suppose then that we wanted to create a function that would calculate the area and circumference of a circle given you fed the radius to it. Okay, so here the prototype, which would be at the very top of the file, would say void calculate, if we call our function calculate, double R, that's the radius, double star C, that tells us where the circumference is going to be stored, double star A, that tells us where the area is going to be stored. Okay, well, suppose later on the file we have our program which is called main, and that we define in there a double called circum and a double called area, and then we have a few more statements, and then we call calculate, that's our function, with the value of 5 for R. The address of circum is going to go in here as the pointer variable, and the address of A, or of area, is going to go in here as the other pointer variable, which is A. A little later on in the file then somewhere is going to be the actual function definition. So here we have void calculate, double R, double star C, double star A. Notice that that looks exactly like the prototype up here, except there's no semicolon at the end. Our simple function then just says take 2 multiplied by pi multiplied by R, store that into the address pointed to by C, which is here, which again remember would be, whoops, back here, our circumference, and then we have pi R squared goes into the address pointed to by A, which again remember is area. So when these two things are accomplished and we hit this last bracket, this function will go away and we'll come back to this very next location here, where circumference now has the value of the circumference and area now has the value of the area. We can do whatever we want there. Eventually we're going to end up with a return 0 and another bracket, which is the end of our program.